and in this video we will be learning about how to use AI for MATLAB and especially for electrical engineers. So in today's world what we are looking at that almost all the codes can be written by AI, but the problem should be yours. This means that if you are having a problem, there is no need to learn coding from the basics. You just need to learn how to prompt to an AI. This in popular language or in Gen Z language is known as vibe coding. So what I've done here is I have one segment for prompting and one segment for the MATLAB is open here. So this is my file which is untitled. I am going to save it with the name AI code for MATLAB. So this is my MATLAB window. So let's start. So we'll be using, I'm using Gemini. You can use any of the AI tool available with you, and there is no need for pro version also. You can use it from the free version or whichever you are having. So traditionally when we write MATLAB codes, we rely on textbook theories like trial and error method, and whenever the errors comes we go back to our books and get there and find there that what is the particular type of error we are getting, or we go to Stack Overflow or something like that, or websites where this problem have been encountered by other coders. So what is the key benefit of AI is that we will save time, we will focus on higher motives. But what is our higher motive? It is a problem solving. So we will be focusing on the problem solving, not on the writing the code. So let's have one example. So let me write here. Let's simulate a RLC circuit, simple RLC circuit, series RLC. So write a MATLAB code. So the prompt I am writing is write a MATLAB code to plot the step response of a series with values where R is equal to, let's say it's 10 ohm, and inductance we can have 0.5 Henry, and C, which is the capacitance, is 100 microfarad. Okay, so this is the prompt I am writing. So I want code for this particular response, and this is a step response, or I can say this is the unit or any step response. The magnitude doesn't matter here. So as I am doing it, so it is finding a perfect solution or whatever the solution. It is not compulsory that every time this solution will be working. So now we have learned a basics of MATLAB, so we can see code also. So I am just copying it from here and I'm pasting it over here. So now what we can see here is, so this green portion which is being marked here, these are the comments only. So first it is clearing the workspace and the command window is now cleared. In second, it is defining circuit parameter like resistance, inductance. So we have to check this, that is AI taking the exact value what we are trying to simulate. And third, it is creating a transfer function for solving this problem. So this is numerator, this is denominator. Then RLC, this TF is a function for making transfer function, so numerator upon denominator, then display transfer function, and then the step response of RLC system, and then the plotting of this, and this is the end of script. So I will be running it. So as I am running it, if the code is correct, then Here we can see these are the values, but it uh, so what is the problem we are finding? This. So this is a particular type of a response which we are getting. So from here I can also copy paste it. This is a capacitor voltage particularly. This is the amplitude voltage. Okay. So this kind of simulation you can also do. You can reiterate it by saying, let's again reiterate it. Let's suppose you don't want this particular type of problem. Okay. Second we can do is, let's suppose I want to do only, let me minimize this, or let me minimize this code portion. Okay. Okay. So this code has been generated, MATLAB code for RLC step response. Now what I want to do is, I want to plot voltage across, or the step response across all the inductances. So I will update this code. So I will be specifying it. I want a figure of 2 by 2 grid, or 2 by 2 figure with two with three, or let's with four sub figures. Each plotting step response across R, L, C and across RLC. Okay, so I'm what I want is, I want step response. So this is a step response across one particular component. So I need across R, across L, across C. So I want to see that what is the response of unit response across each of these components. So I will be writing this. I want a figure, which figure will be having four figure inside it, which is the sub figure. And now update the code. Now update the code. Okay, so this will be updating my code, and I'll be again copy pasting it. So no need to keep this code we can delete also. So I'll be writing another this using Gemini. I am writing another code. So this code will be updated code. Okay, it is now plotting four things. So this, okay, now again I will be running it, and I will be maximizing it. Okay, so these are the four curves. So this is the voltage across capacitance, this is the voltage across resistance, this is the total voltage across RLC, which is now 1, and this is the voltage across inductor. So everywhere you can see the transient, and this is a typical case of step response across RLC circuit. So it is a second order circuit, you might be knowing. So we are not going into the electrical engineering, just telling you that how using MATLAB we can now code. Now what we can do, we can change the values of resistance. Like, let me change the resistance value to 20. So for this I don't need code. You can do this by AI also, but because I understand coding a bit, so what I am doing is, I know these are the circuit parameter, I will be changing here only. So I will be reducing this to 0.25, and these are the new values. Now I will be updating and seeing what is the impact on the response. So because I have increased the resistance, the response, the oscillatory nature of the circuit has been reduced. So this is one of the typical example. So what I can do next is, I can have another code and this code will be, let's say, example, uh, let's say we have to write for the motor. Let's write for the motor. So write MATLAB code to plot torque speed characteristic of an induction motor. Okay, or for so I need to specify the rating. So motor for a 5 HP 415 volt 50 hertz motor with current limit of okay. So this is the values I have given, and take others. So why I am writing this much is because I want to specify to the AI that this is the particular rating of my motor. So I don't want him to confuse or give me random values, because AI can give you random values because it actually doesn't know what induction motor is. It just collect words from you and process it using words. It is kind of a word processing, so it doesn't exactly know your problem, so you have to specify it, and it would be good if you can specify it in point wise. So take okay, so now I'll be going write a MATLAB code to plot torque versus speed graph of induction motor, and what is the rating. So I have given basic rating 5 HP 415 volt 50 hertz motor, line current is around 6.5. So this is what. So let's see what it will be giving. So this is thinking, you can also see it is calculating motor parameters. So it has taken these parameters, means the resistance, magnetizing inductance, according to itself, according to him only. So it might have searched the web or internet, and it have seen that this particular 5 HP motor has this particular kind of characteristic, or this kind of parameters. So now I'll be copying it and I'll be taking it here. So I am writing here, okay, and I'll be running it. So let's see what is the characteristic. So this is a and this characteristic is actually looking good. So what we can see here is this is a torque slip characteristic. Okay, let me again run it. Okay, so this is, so we can extract it also. Okay, let me see. So this is a torque speed characteristic, and this red one is the current limit. So this current limit is, it has shown here. So what I can do here is current limit is 6.5 ampere. If I can zoom it, yes. So the current limit is 6.5 ampere. Starting torque is 42 Newton meter. Maximum torque is 70 Newton meter, and rated point is around 18.9. Okay, so it has a very good starting torque. It has a this green star is showing the rated point, and this is showing the our rated point, or which is at the current limit. So this torque speed characteristic, we are not going into the induction motor. So the purpose of this video is to generate a code using the prompts for particularly for the electrical engineer. So these are the two examples, and we have seen here. So we can change rating also. Okay, this is a graph. So this is the code. So for writing around 120 line code, you will be taking maybe 1 day or 2 days, because you have to think what kind of code or function you have to use, and this using AI you can write it quickly. So this is what is the power of artificial intelligence, because it is saving you time and it is giving you time to focus on the higher version or the higher uh, level of problem. So from the next video what we will be doing is we will be focusing on electrical problem, and for coding and other purposes we will be using AI only. So we will be learning both. We will be using how to prompt an AI for an electrical engineer, and we will be learning electrical engineering as well, especially related to electric vehicle or green energies. We will be focusing on there only. So thank you.